All right, guys, we're going to talk about tire and wheel service. This is pretty big. There's a lot of information here, so I'm going to break this up just so that it fits what we're doing in Canvas better. So we're going to talk about the importance of proper inflation pressure, how to inspect both the inflation pressure and the tread depth, the two types of pressure monitoring systems, and the two types of tire pressure sensors. And then we'll also take a look at the 8 most common uneven or irregular tread wear patterns. And we'll take a look at what causes those irregular patterns. All right, so underinflation is going to cause tread wear to be on the sides of our tires because the sidewall is the stiffest part of the tire, and that is going to cause the tire to go concave like this, and it will ride on the outside edges of our tire, where overinflation will cause this to go kind of convex, and it will lift the outside edges off and will wear the center of the tire. So we need to make sure that we have the correct tire pressures run in our tires. It's going to increase the tire's life. It's going to have safe and predictable handling, and it will also give us the expected fuel economy that we require. All right, so recommended tire pressures vary depending upon tire size and application. Specifications for the inflation pressure can be found on the tire and loading information label that is located in the driver's door pillar. It can also be sometimes found in the door, and also sometimes you might find this in the glove box. But if you cannot find it on the vehicle, you're going to need to look this up for the vehicle. You can find it in service information. There's all kinds of information here. It tells us what the car is required to have on it. So factory installed, this vehicle had a 225/50 R17 tire. We need to run this at 33 PSI, not what is told or located on the tire. A lot of times our tires are going to say that the maximum pressure could be like, say, for example, 40 PSI or 45 PSI. Even though it says that on the tire, we always inflate to what is located or what is indicated on the tire placard that is on the vehicle. You also do not want to rely on a visual inspection of the tires to say, ooh, that that tire looks low, or that tire looks like it might be overinflated. You can't tell by looking at the tire. You will only see the extreme, which means that you have to put a gauge on it, and you need to know exactly what the pressure is inside the tire. When we get further into this, we're going to talk about how the temperature of a tire will affect its inflation pressures. So just realize that tire pressures do change as the tire heats up and cools down. All right, so now we're going to move into our TPMS, or tire pressure monitoring system. We're going to have two types. We're going to have direct sensing, which is means that we will have a tire pressure sensor in each of our tires. We will also have a tire pressure monitoring ECU, and we have all these other pieces here that are required to operate using these direct type sensing devices. Previously, we used to use this system called indirect sensing. Indirect meant that we were using the ABS wheel speed sensors to determine if we had a low tire. We found that that wasn't accurate enough to meet the federal guidelines, and so manufacturers had to go to a direct type sensor like this. And now the engineers have figured out a way to go back to using the wheel speed sensors. And so cars or manufacturers are beginning to move away from having a direct sensor back to the indirect sensing, which is cheaper. If you don't have to have a $10 sensor in every tire, it makes manufacturing the vehicle that much cheaper. So the industry is moving back to an indirect way of sensing tire pressure. Now, vehicles that do have this tire pressure monitoring system display, you will see that it displays all of the individual tires, and many times it tells what position they're in. So, and this is going to include the spare tire. So, on vehicles where you have a spare tire on the back of the vehicle, and you're fighting a TPMS sensor light, just remember that sometimes we do have a TPMS sensor in the spare tire, which means that if it's under a plastic shell, you're going to have to remove this plastic shell to gain access to the tire. One case in point would be like an FJ Cruiser. They have a plastic shell over the tire. Another one that was like that was the Honda CRV. They have a spare tire mounted to the back door of the car, and it does have a sensor in it, so just be aware of that. Even if the vehicle doesn't have this type of display where it's listing all the tires, you can obviously see that there's 5 tires here. There's many cars that don't show the individual tire pressures but still take into account the spare. All right, so here's what a sensor looks like. The information that is going to be broadcast from each of these sensors will be the speed at which they communicate, the frequency. This is very important. If you put the wrong type of frequency sensor in the car, it's not going to communicate. How much it weighs, the kind, and the 7-digit number. So what we're going to be seeing when we look at these really is the frequency, the ID number, and the temperature of the air inside the tire. These do have batteries in them. They last about 10 years, and after 10 years, it's going to be time to replace them. So if a customer comes in and they say, hey, my light's on, you discover that one of the batteries in the tire and the sensor is low or bad, you need to recommend that they replace all of these as a set, because once they get to be about 10 years old, it's time to replace them. So the tire pressure sensor is mounted on or in the rim like this. We have a couple different types. This is the most typical, where we have an aluminum stem. And we have a nut here with 2 washers and a sealing grommet here. So when we replace these sensors, or when we service the sensor, we're going to replace this nut, the washers, and the sealing grommet that is here. This is unique to Toyota. Some of their vehicles will have this button in the vehicle. You'll find this typically to the left of the steering wheel. There is a procedure that you must follow. I am not going to go through it here. This is something that you'll just have to look up when you're dealing with a Toyota product that has this button. Essentially, we can have 2 sets of tires, and this button facilitates that. It makes it easy for the owner, if the owner was living in a climate where they have a set of summer tires and they have a set of snow tires that are studded. So, of course, you're going to have your summer tires during the dry months, summer, and then during the snow season, you'll have your snow tires, and you can seamlessly switch between those 2 sets of tires and have the TPMS system be operational. So when dealing with TPMS, we are going to, if you're dealing with factory stuff, you're going to be using a scan tool. This is what the Toyota factory scan tool used to look like. It's still computer based, but it's much smaller than this. You're going to need a accurate tire gauge, and we'll be using this tire TPMS system tester. This basically makes the sensor turn on inside the tire, and it broadcasts all the information that's required to program the sensors to the car. So here's some additional information. When you're doing the factory way, we will use the special tool to get the sensor ID information. You write that information down, and then using a wizard in the scan tool, we have to manually type those sensor IDs into the wizard, and it will relearn or program where those sensors are located on the tire or on the car. We have an aftermarket tool that we'll be using at the college, which makes this much easier, where the tool does all of the hard work. You just scan each tire sensor, and then we connect using the OBD2 port, and we relearn or reprogram the sensor IDs to the car. Much easier than the factory way. Go past this stuff right here. Okay, so this is really important, and it's sometimes people don't really think about it, but tire pressure will increase and decrease with tire temperature. As the air in the tire becomes warmer, the tire pressure increases, and the inverse is true. As the temperature in the tire becomes colder, the pressure is going to decrease. So if the tire pressure is set when the tire is warm, then when the tire cools off, the pressure will drop. And so if the tire pressure is set when the tire is hot or the outdoor temperature becomes very cold, the pressure drop due to tire cooling can cause the TPMS light to come on. So here we are. If we're dealing with a hot tire, basically what we're saying is that if you're dealing with a hot tire, you're going to have to set it higher so that when the tire temperature comes down, the pressure drop will keep it in the range. So you can see a hot versus a cold tire, and they actually make a calculator to determine how much tire pressure does the tire need in order to keep the TPMS TPMS light off. San Diego doesn't typically have these large temperature variations, so we don't see it very much, but when you're in climates where you could have a 30-degree swing, such as like Arizona, where the outside temperature could be well over 100 degrees, and then at night and you have the vehicle in the garage where it actually can get cooler, the customer might experience a TPMS light because the pressure has dropped so much inside the tire due to this variation in the tire temperature. So this is something that you just need to be aware of. And they do make online calculators that you can find doing a quick Google search. All right, so here is the indirect TPMS system that has been used. Again, we're going to be using, or the system will be using, the speed sensors at each wheel, and with an algorithm that the engineers have figured out, and it will use the information coming from the speed sensors to determine if we have a low tire. There is this act called the TREAD Act, and basically, if you can remember back, or if you do a quick search, Ford Explorers with Firestone tires were blowing up and causing these Explorers to roll over and kill people. And so the federal government figured out that the tires were blowing up or losing the tread for two reasons. One was the tire was not a good tire that Firestone was creating, and that problem was exacerbated because the Ford engineers decided to set the tire pressure really low from the factory. Like, I think the standard tire inflation was like 28 pounds, and people don't check their tire pressures very often, and so having a bad tire coupled with low tire inflation pressures caused this tire to overheat, and the tread would peel off. And then when that would happen, it would cause this Ford Explorer to roll over and kill people. So the federal government decided that manufacturers have to be able to determine when we have a low tire, and this is why we have TPMS systems today. And so in this Tread Act, it said that the manufacturers had to design a system that could tell when 2 or more tires were low. In the old days, indirect sensing can only determine if 1 tire was low. Now the engineers have figured out how to use the speed sensor to determine when to meet that specification of being able to say 2 or more tires are low, and to be able to determine which wheel the low tire is located at. So again, it's in the manufacturer's interest to move away from having direct sensing back to this indirect sensing, because they save the money of not having a sensor in the tire, and they use all of the other stuff, all the other wiring and the ABS unit that's already in the car. So that's why we're moving back to this. So if you could think about it, when a tire is properly inflated, it's going to have a larger diameter, overall diameter, than a tire that is flat. And as the tire pressure falls in the tire, its diameter is going to become smaller and smaller, which means it has to spin faster to keep up with the rest of the other tires. And these speed sensors are so accurate now that it can determine when a tire is underinflated. So on these indirect sensing types, it's going to have much of the same. I mean, this looks just like a car with regular ABS. Again, we are using the ABS wheel speed sensors to determine if we have a low tire, because again, the tire will be spinning faster to keep up. The underinflated tire will spin faster to keep up with the other tires that are properly inflated. And we're still going to have a TPMS warning light. It's everything that we're already used to seeing. So these are different factors that can cause the TPMS system not to operate properly. So just be aware that these things can cause the system not to operate correctly. All right, so let's move on to tread depth. We're going to wrap up this guy here just when we talk about tread depth. And then the next portion is going to be wheel balancing, but we're going to separate that out. So treadwear is basically the service life of a tire depends primarily upon treadwear. And so as the tire tread surface wears, its traction capability decreases, along with the safety and handling performance of the vehicle. So of course, a brand new tire is going to handle and stop better than a tire that is worn. Please take a look at the YouTube video I put up there, put up in Canvas, that shows the difference in the ability of these cars and trucks to stop with tires that are worn. It's pretty interesting to see that. The amount of tread remaining on tires should be inspected whenever a vehicle is brought in for service, and we want to make sure that the tire is wearing properly. If it's not, then we need to address that. And sometimes when you find a tire that is wearing incorrectly, you're going to have to determine why that tire is not wearing correctly. And it's going to cost money for the customer to fix it. And once a tire begins to wear incorrectly, often the only fix is to fix the problem with the vehicle and then replace those tires. And I've seen brand new tires get destroyed very quickly. I'm talking like 5,000–6,000 miles. So the tread depth is going to be measured. Is the measured distance from the outer tread surface to the tire body piles. The best way to measure the tread depth is with a tread depth gauge. And we want to measure in 3 to 4 places across the tire That way, if we see the tread depth different from, different parts of the tire, we can determine how it is wearing. So if it's worn in a wedge shape, obviously we're going to have to deal with that. There's all kinds of different ways that the tires can wear, and we'll take a look at a picture of that. And the minimum allowable tread depth is 2/32, which is not a whole lot. And this is not a very good picture, but tires have these things called wear bars, and it's basically a solid piece of rubber that goes across the tread in many different places around the tire. That way you can quickly determine if once it hits the wear bar, that tire is junk. It's time to replace it. All right, so here are many different ways in which a tire can have problems. So low tire pressure, high tire pressure with it wearing in the center. If you see something like this, to me, this is more of an alignment issue. Typical high-speed, our cars basically drive from point A to point B, and customers are not high-performance driving these vehicles. If you see something like this is like a tire, sorry, this is an alignment issue. This could be a toe wear. So the vehicle could be experiencing where the tires are pointed in, they're kind of snow plowing, or they're pointing outwards, or camber wear can kind of look like this. We can go crazy with this, but just realize that there's all kinds of problems. I know this is saying this is toe wear, but toe tends to wipe out a tire from the center all the way to the outside edge. So just be aware of that. Camber is going to cause a tire to go bald just on one outside edge. I'm going to post up some more information or more videos from Honda. They do a very good job of talking about this. If we have a cupped tire, it could be because of lack of rotating the tire. Some cars, we have different size tires front and back with directional tires. Unfortunately, with a car like that, you can't rotate the tires. It is what it is. But if you have a vehicle where you can rotate the tires from front to back, cross them, we'll talk about tire rotation patterns soon. You need to be doing that. I like to do it every oil change. It just makes the tires last that much longer. When you have something like this, when a tire, this is pretty crazy. I'll see if I can find some pictures. I used to have a tire at the school that had this crazy cupping wear. This is typically, you'll find it on the rear of the vehicle, and it has a toe problem, and it will actually drag the tire and create this crazy tread wear pattern. It's kind of rare, but when you find it, it's like, how did the tire get worn like that? And it's pretty crazy. So anyways, we'll move into, well, let me just take a look at tire rotation patterns. There's a couple different ways in which we can rotate the tires front to back like this. This one's including the spare tire. I like to do this thing called a modified rear cross, where I take the rear tires and I move them to the front, and then I cross the tires from the front to the back. So the rear tires are just going to move forward, and then I cross the fronts to the back. I tend to do that on every vehicle, whether it's front wheel drive, rear wheel drive, truck. I'd like to do that as long as they are not directional tires. If they are directional tires, you have no choice. You have to move them front to back. And if if it has a staggered fitment, meaning that the front tires are different than the rear tires, a different size. For example, I have a BMW 335i. The front tires are narrower than the rear. Unfortunately, you cannot rotate these tires, and they're directional. So the only way that I would be able to rotate the tires on this car would be to actually dismount the tire from the rim, and put it on this rim over here. That'd be the only way I could do it, but it doesn't really achieve anything. All right, so we're going to move on into wheel balance, but I'm going to save that for another video. So I hope you are doing well. Please reach out to me on Canvas if you have any questions. and we'll, of course, be working in the lab as we go. All right, have a good day.